In this example, we want to graph the line y equals 5x plus 2. So we've learned how to figure out what the equation line is. Now we have the equation line and we want to graph it. So remember that the form of every line is going to be y equals slope times x plus the intercept. So when I look at this, the number that's attached to the x, that's going to be your slope. So my slope equals 5. And then the number you add is your intercept. So my intercept equals 2. Now slope is always equal to rise over run. So you want to take that 5 and make it a fraction. Now if it's not already a fraction, to make something a fraction, you just say divide by 1. Because if you think about it, dividing by 1 won't actually do anything. So you have 5 divided by 1, which gives you, well, it is equal to 5. But we want to leave it as 5 over 1. So we can say we will go up 5 and over 1. Now you also need your intercept. The intercept is 2, which means if x equals 0, y equals 2. So we do the intercept first to have a point to start. So you go, this is your x-axis, this is your y-axis. It helps to label those. So if x equals 0, y equals 2. So I have this point right here. Now my slope is 5 over 1. So I go up 1, 2, 3, 4, 5, and over 1. And drawing a line. This is a math class, again, so we're not super picky. We just need to know, can you find the intercept? Can you find the slope? Our next example, let's graph the line y equals -4/7 x plus 3. So remember, the number multiplying your x is your slope, so my slope is -4 over 7. And my intercept equals 3. So when I look at the slope, this is negative. So there's two ways you can do this. The easiest way for me is to look at this and just put the negative with the 4. So my rise is going to be -4 over 7. So this means we'll go down 4 and over 7. My intercept is 3, so that means if x equals 0, y equals 3. So label your axes, x and y. If x equals 0, y equals 1, 2, 3. So here's my starting point, and then I need to go down 4 over 7. 1, 2, 3, 4, 6, 7. So here are my 2 points. Draw the straightest line you can through 2 points. Our next example, graph the line y equals 3x minus 2. So my slope equals 3, it's the number times x, and my intercept equals -2, or in this case, -2. So slope is rise over run. So 3 is not a fraction, so we need to make it a fraction. So we'll say 3 over 1. So that means we will go up 3 and over 1. So, and my intercept is -2. That means if x equals 0, y equals -2. So y is -2 when x equals 0. There's my starting point. And my slope is up 3 over 1. So up 1, 2, 3 over 1. Now I've only done 2 points. If you want, you could find another point by going up 1, 2, 3 over 1, 1, 2, 3 over 1. So you can get a few more points. Not strictly necessary because, again, this isn't a math class, so we're not super worried about this being exact. We just need to know that you understand slope and intercept. Now here's the part that will really be handy for statistics. Independent and dependent variables. In mathematics, when we graph a line, we have independent x and dependent y variables. The idea is that the dependent y variable somehow depends on or usually can be explained by the independent variable x. So in statistics, we have special names. X is called our independent variable, or sometimes we call it explanatory variable. Y is our dependent or response variable. That's because in statistics, we're going to use our explanatory variable x to explain or predict the behavior of our response variable, y. So we'll use x to explain y. That's what we do in statistics. These are just a few word problems to help you out with creating equations of lines. So for example, when a plumber is called, the cost of a service is $50 for him to show up at your house, plus an additional $25 per hour. So we want to write and graph an equation to show this relationship. So you need to figure out what are your independent and dependent variables. Now, sometimes there's not a specific way that you would have to do this, but to me, it would make sense that if I know how long he's at my house, I want to find out the time. So the cost. So I probably want to use the time to explain the cost. So we want to use time to explain cost. So if we're doing it that way, then time is going to be x and cost will be y. So let's label our axes. Here we will have here we will have time, and on the y-axis we will have cost. Let's see. So what are my independent and dependent variables? X, or my independent, or my explanatory, is going to be time. And y, which is called my dependent, or my response variable, is going to be the cost. So I can use time to explain cost. So we need to know two things. We need to know our intercept, and we need to know our slope. So for my intercept, this means, well, if x equals 0, then y equals what? So let's think about that. He said it costs $50 just to show up. So that means before he does anything else is $50. So even if he doesn't stay there more than 1 second, he's going to charge you $50. So my intercept is going to be 50. So my intercept equals 50. My slope is I have to have some kind of change. So my slope, instead of rise over run, we'll write change in y over change in x. So it says an additional $25 per hour. So that means if he stays 1 hour, so if time or x is 1, then it's an extra $25. So my slope is going to be 25 over 1, or just 25. So I know my slope, and I know my intercept. Let's put them into my line. So the equation of my line is always y equals my slope times x plus the intercept. So in our case, our slope is 25, so it's going to be 25 times x plus my intercept of 50. When I come over here, I do want to label everything, so my time can be in 0 hours, 1, 2, 3, 4. You'll notice I'm not bothering with negatives because I'm not going to have negative time or negative money. And my cost, I'll do $25 increments. Okay, so I have time, I have cost. Let's look at it. First, I need my intercept. So when x is 0, so before he even spends any time, I have to pay $50. So my first point will be here at 0 and 50. Sorry, my computer is having issues today. And then my slope is 25. So rise over run, up 25 over 1. Up 25, which is from 50 to 75, and over 1. So the equation of the line looks like this. For our next example, you have a job at the custom tee shop where t-shirts are printed to order. For each order, custom tee shop charges $8 per shirt plus a one-time setup fee of $15. So that means the one-time setup fee equals 15. So that means before anything else, you're paying $15. And then $8 per shirt. So the one-time fee is always going to be your slope. The per shirt is going to be, the one-time fee is going to be your intercept. The slope is going to be the per shirt. Okay, let's start with what are your response and explanatory variables. So your response, or your Y value, is going to be what you want to predict. Your explanatory is your X, what you'll use to explain it. So you probably want to predict the money or the cost. And you'll probably explain that with the number of shirts. So over here, we'll put number of shirts. And on the y-axis, we'll put the cost. Let's find our intercept. The intercept is if X is 0, Y is what? So before I even buy any shirts, I have to pay that one-time fee. So it's going to be the one-time fee of $15. And my slope, which again is always equal to rides over run, would be 8. Because for every extra shirt, you have to pay $8. And so the equation of the line is always slope of 8 times X plus the intercept of 15. So there's the equation of our line. Now to graph it, we'll need our number of shirts. So 1, 2, 3, 4, 5, 6. For my cost, I could pick different scales. I will go by a scale of, say, 5, 10, 15, 20, 25, 30. So for my intercept at 0, I should be starting at $15. And then for every extra shirt, I have to go up $8. So I'm going to go up 8 and over 1. So one shirt costs me $8 more. And then if I go up another 8, about here, and over 1, that would be my next point. Now, if you're going to be more particular, your cost, I could probably say cost is going to be in dollars, because that was my units. And our final example, let's suppose a town had a population of 5,000 residents, but the population is decreasing by 200 people each year. Okay, so X for my independent or explanatory would be the year. And Y, my dependent, or the response variable, is going to be the population. Sometimes we call X independent because notice the year is not really affected by the population. You can't change the year. The year just keeps marching on no matter what you do. It's the population that is affected by the time. So here we will have year. Over here we will have population. And let's see. First we'll find our intercept. This means when X equals 0, what is it? Now the year isn't necessarily 0, but for us, we'll have, starting at 0, we had 5,000 residents. So the year is, it didn't really tell us a year, but we'll say the starting is 0. And our slope is every year it's decreasing. So our slope is going to be negative 200 because every year it goes down. Then y is going to be equal to negative 200 times x plus 5,000. So when I try and graph this, I'll probably use a scale of about 500. So 500, 1,000, 1,500, 2,000, 3,000, 4,000, 5,000. So my intercept when x is 0, y equals 5,000. And my slope, we're going to have rise over run. So we're going to go down negative 200 and over 1 year. Oh, I didn't label my years. 0, 1, 2, 3, 4. So we'll go down 200, which should be probably about here, and over 1. Down 200, over 1, etc.